Pressure is generally expressed in the following terms, that are atmospheric pressure, gauge pressure, vacuum pressure, and absolute pressure. Now we are going to discuss about one by one. First we are going to discuss about atmospheric pressure. It is the pressure extended by atmospheric air on any surface. It is measured by barometer. Its standard values are 1. The atmospheric pressure, that is equal to 160 mm of Hg. Atmospheric pressure is equal to 760 mm of Hg. That means mm of mercury. This is the pressure head. Pressure equal to what? Atmospheric pressure is equal to any pressure equal to WH. This is the standard formula. This is equal to W is nothing but rho g into H. But what is rho? Rho is nothing but density of mercury. Density of mercury is equal to specific gravity of mercury into density of standard liquid. Right? Specific gravity of mercury is 13.6 into density of standard liquid is 1000 kg per meter cube. This is the density of mercury into G 9.81 into H, that is given 760 mm of Hg. That means 760, that converts into 760 divided by 1000. This is converts into meters of Hg. Right now the pressure P is equal to 101.32 kilonewton per meter square. Right? The atmospheric pressure is expressed as in pressure head, that is atmospheric pressure is equal to 760 mm of Hg or 760 divided by 1000 meters of Hg. Then that pressure head converts into pressure, atmospheric pressure. Atmospheric pressure is equal to 101.72 kilonewton per meter square. That is the atmospheric pressure always acting on the surfaces. This is about atmospheric pressure. Gauge pressure. Gauge pressure means the pressure above the atmospheric pressure, that is known as gauge pressure. It is the pressure of fluid contained in a closed vessel. It is always more than the atmospheric pressure. It is measured by an instrument called pressure gauge. The gauge pressure is measured by using the pressure gauge. The gauge pressure is always above the atmospheric pressure. And the vacuum pressure. Some points related to the vacuum pressure. It is the pressure of fluid which is always less than the atmospheric pressure. Vacuum pressure is always less than the atmospheric pressure. The diagram I will show in the next slide. Pressure in steam conditioner is one such example of the vacuum pressure. It is also measured by pressure gauges, but the gauge reading on negative side of the atmospheric pressure. But this is also measured by using the pressure gauge, but the pressure reading is on negative side of the atmospheric pressure. Right. The vacuum represents a difference between absolute and atmospheric pressure. The vacuum represents the difference between the atmospheric and vacuum pressure, that I will show here. Right. First we are going to discuss about what is absolute pressure. Then I am going to show the diagram related to. Now first we are going to discuss about absolute pressure. Then I am going to show the diagram relation between the absolute pressure, atmospheric pressure, and gauge pressure, and also vacuum pressure. Right, what is absolute pressure? It is the pressure of fluid. It is pressure of fluid which is measured with reference to absolute zero pressure. As a reference, the absolute pressure is more than the atmospheric pressure or less than the atmospheric pressure, depends upon the pressure gauge shows the reading, that is negative pressure or positive pressure. Right. Absolute pressure is equal to atmospheric pressure plus gauge pressure, and vacuum pressure is equal to atmospheric pressure minus gauge pressure. These are the relations between the atmospheric pressure, absolute pressure, atmospheric pressure, and gauge pressure, and also vacuum pressure, atmospheric pressure, and gauge pressure. Right. This is the diagram. This line represents atmospheric pressure. This is the atmospheric pressure. The pressure above the atmospheric pressure is known as gauge pressure. The pressure above the, this is the atmospheric pressure. The pressure above the atmospheric pressure is known as gauge pressure. The pressure below the atmospheric pressure is known as vacuum pressure. Then one more point. This is the absolute zero pressure. This is absolute zero pressure. The pressure above absolute zero, this is absolute pressure. The pressure above absolute zero is known as absolute pressure. And also the pressure above absolute zero is known as, this is also known as absolute pressure. Right? Based on this diagram, once again, this is the atmospheric pressure. Above the atmospheric pressure is gauge pressure. This is the atmospheric pressure. Below the atmospheric pressure is known as vacuum pressure. This is the absolute zero line, reference line. Above the absolute zero line is known as absolute pressure. And also here, this absolute pressure is more than the atmospheric pressure. This is the absolute pressure. This is below the atmospheric pressure. This absolute pressure below the atmospheric pressure. This absolute pressure above the atmospheric pressure. This absolute pressure below atmospheric pressure. Now the relation between these absolute pressure is equal to, this is the absolute pressure, first case. Absolute pressure is equal to, this is pressure plus this is gauge pressure. Atmospheric pressure plus gauge pressure, that is the absolute pressure. And one more formula for the determination of absolute pressure. This absolute pressure is below the atmospheric pressure. Absolute pressure is equal to atmospheric pressure. This is atmospheric pressure. This is the atmospheric pressure. This is atmospheric pressure. This is vacuum pressure. Therefore, this is absolute pressure. Absolute pressure is equal to atmospheric pressure minus vacuum pressure. Absolute pressure is equal to atmospheric pressure minus vacuum pressure. Right? Based on the pressure that is above the atmospheric pressure or below the atmospheric pressure, the absolute pressure is equal to atmospheric pressure plus gauge pressure, or absolute pressure is equal to atmospheric pressure minus gauge pressure. This is the relation between the atmospheric pressure, vacuum pressure, gauge pressure, and absolute pressure. Pressure is defined as force per unit area in a direction perpendicular to the surface of object. This is, suppose, one tank. This is filled with water. This is filled with water. The pressure intensity is at top is equal to 0, at bottom is equal to maximum. That is, this is the pressure distribution diagram. Intensity of pressure or pressure distribution diagram. Therefore, the pressure is maximum here, pressure is equal to 0 here. The pressure at this point is equal to P is equal to WH. Pressure is defined as the force per unit area. This pressure is defined as force per unit area that is acting normal to the surface. This is always acting normal to the surface. The pressure is the amount of force acting on unit area. This is compressive stress on fluid and mathematically expressed as force equal to pressure into area, or intensity of pressure P is equal to force by area. What are the units of intensity of pressure? Force equal to force units newtons, area units meter square. Therefore, the units of pressure or intensity of pressure is equal to Newton per meter square. Right? Newton per meter square is also known as Pascal. Sometimes Newton per meter square is also known as 1 Pascal. 1 Newton per meter square is equal to 1 Pascal. Right now, 1 Pascal is equal to 1 Newton per meter square. 1 kilopascal is equal to 1000 Newton per meter square. 1 bar equal to 1000 kilopascals or 10 power 5 Newton per meter square. 10 power 5 Newton per meter square. These are the relations we are used where we are going to solve the problems. Right. Right, what is manometer? Manometer is the device which is used to measure the pressure at a point by balancing the column of liquid by the same or another column of liquid. This is about manometer. Manometers are basically classified as different types, that is simple manometer, differential manometer, micro manometer. Now we are going to discuss about one by one. A simple manometer consists of glass tube. The both ends of the glass tube is opened. One of its end is connected to where the pressure is to be determined, and the another end is open to the atmospheric. A simple manometer is a glass tube. One of its end is connected to where the pressure is to be determined, and another end is open to the atmospheric. The simple manometers are classified as piezometer, U-tube manometer, and U-tube manometer two ways. One is for measuring the gauge pressure, and another one is for the measurement of vacuum pressure. And another classification, single column manometer and inclined tube manometer or sensitive manometer. These are the types of simple manometers. Piezometer. Right here, this is one pipeline. Here we are going to install one glass tube like this. This glass tube is also nothing but piezometer. One of its end is connected to where the pressure is to be determined, and another end is open to the atmospheric. So because of the pressure in the pipeline, the liquid moves like this and raised up to this level. Therefore this level is denoted that is H. The center line of the pipe to the top level is denoted by H. This H is used to determination of pressure intensity. We know one formula for the determination of pressure intensity. The pressure at point A equal to WH. W is the unit weight of liquid, any liquid flowing through the pipe. That is equal to rho G into H. Rho is the density of the flowing liquid. G is the acceleration due to gravity. H is the level raised in the piezometer. This is the formula for the determination of pressure at point B by using the piezometer. Right? U-tube manometer. U-tube manometer is also simple manometer. Here, in case of U-tube manometer, having one U-tube, in case of U-tube manometer, one U-tube like this. One of its end is connected to where the pressure is to be determined, and another end is open to the atmospheric. This is known as U-tube manometer. But here, this is the pipeline. The liquid is flowing through the pipe. The one of the U-tube manometer is connected here. Because of the U-tube connected here, before connecting the U-tube, suppose this is the mercury level. This is the mercury level. This is the datum line. Mercury level in the tube. This is mercury. In case of U-tube manometer, one is U-tube. One of its end is connected where the pressure is to be determined, and another end is open to the atmospheric, and this U-tube is filled with heavy liquid. The specific gravity of heavy liquid is greater than the specific gravity of this heavy liquid is greater than the specific gravity of the flowing liquid in the pipe. Right? Therefore, before connecting the pipe, this is the mercury level. Once the tube is connected here, because of the high pressure in this pipeline, the liquid is moving like this. Automatically, the mercury level, this is the datum level of the mercury. Right? Now, what is happening? Because of the connection of the one of the end of the U-tube to the pipe, the mercury level, the high pressure in the pipe, this is the liquid moving like this. Automatically this is moving like this. The water liquid is moving in this direction. Automatically the mercury moving towards this direction. Here, this is the level H1, that is the liquid level. This is the level H2, this is the mercury level. This is the datum line AA. Now we are going to determine the pressure at a point B, that I will explain later. Next slide. This is the, in case of positive pressure, the pressure in the pipe is positive, automatically the mercury level moving towards right side. Whereas in case of pressure in the pipe is negative, automatically the mercury level moving towards left side. Here, This is the H1 is the level of liquid flowing in the pipe. H2 is the level of mercury in the manometer. Right? This is the datum line. Now we are going to derive the expressions. Now we are going to derive the expressions for the gauge pressure and vacuum pressure by using the YouTube manometer. Okay, now we are going to discuss about one by one types of manometers. At the end, I am going to derive the expression for the positive gauge pressure and negative gauge pressure. Now, this is single column manometer is the modified form of the YouTube manometer. In case of single column manometer, in the left limb, this is left limb, this is right limb. In the left limb, we are going to provide a large reservoir like this. This is the large reservoir. The cross-sectional area of the large reservoir is 100 times the cross-sectional area of the pipe. The cross-sectional area of the large reservoir is 100 times the cross-sectional area of the pipe. Here that is only the change as compared with the YouTube manometer. Now, because of this one of the end connected to the pipe, because of the high pressure in the pipe, this large reservoir, the change in the liquid level, in the large reservoir is very, very small. This is the change in the depth. This is the change in the depth of the reservoir. Because of small change in the depth in the left limb, the right limb, the change is too high. This is the difference between the single column manometer and YouTube manometer. Next classification, inclined tube manometer. This is as like a single column manometer, but only the difference is inclined tube manometer. This is as like as single column manometer. Only the difference is in the earlier case we have determined the H2 is directly we have, that is because that is vertical single column manometer. Here inclined single column manometer, this is the inclined single column manometer, this H2 is determined. This is theta, right? This is length L, this is height H, this is length L, this is theta. Now we are going to determine H. Earlier case we have directly got the H, but here sin theta equal to opposite side H2 divided by hypotenuse is nothing but L. Therefore, H2 is equal to L sin theta. This is the only difference between the single column manometer and inclined manometer. Right? The type of inclined micromanometer is more sensitive than the vertical tube type. Due to inclination, the distance moved by the heavy liquid in the right limb is comparatively more. Thus, it can give a high reading of the given pressure. Right? This is the only difference for the determination of H2 is equal to L sin theta. Right? Thus, it can give high reading for the given pressure. Right? This is about inclined manometer. Differential manometers. What are the differential manometers? What is the purpose of the differential manometers? Differential manometers are the devices which is used to determine the pressure difference between 2 points. That may be same pipe or different pipes. Suppose this is one pipeline, this is another pipeline. We are going to determine the pressure difference between these two. Now we are going to install one tube like this. This is nothing but differential manometer. The main purpose of the differential manometer is determined like this is point A, this is point B. The pressure at point A is PA, the pressure at point B is PB. The difference between or PA minus PB or PB minus PA, the difference between these two pipelines, the pressure difference between these two are determined by using the differential manometer. Differential manometers are different types, that are U-tube differential manometer and inverted differential manometer. Right, U-tube differential manometer. Here the pipelines are different. This is one level pipeline, this is another level pipe, this is the datum line. Right? Now this is one pipeline, this is another pipeline. Here also having one U-tube. The tube is connected here, one end of the U-tube is connected here and another end of the U-tube is connected here. Because of the high pressure in the pipe B, the liquid, the manometer liquid, the heavy liquid moving towards this side. Right? Moving towards this side. This is nothing but H is the depth of heavy liquid. So this is the level, center line of the pipe to the top of the mercury level. This is H is the liquid level of pipe B, Y is the liquid level of pipe A, right? This is where the two different the pipes are at different the points are at different levels, whereas here the 2 points are at same level. This is the U-tube differential manometer, right? Here also the pressure is more here because of the high pressure. High pressure, the liquid moving like this, the heavy liquid moving towards right side. This is H, this is X, as like as earlier case. Therefore the distance, this is equal to X plus H. This is equal to X plus H. This total distance is equal to X plus H, right? Inverted differential manometer. This is inverted differential manometer. Here also that U-tube is provided in a different way, that is inverted shape. Inverted differential manometer is used to measure the very low pressures, and also in case of inverted differential manometer, the manometer liquid specific gravity is less than the specific gravity of the flowing liquid in the pipe A, or the specific gravity of the flowing liquid in the pipe B. That is the only difference. Earlier cases, the manometer liquid specific gravity is greater than where we are going to determine the pressure of the flowing liquid, but here the manometer liquid specific gravity is less than the specific gravity of the flowing liquid pipe B or specific gravity of the flowing liquid pipe A, right? Advantages of manometers. It is simple to construct. Following are the main advantages of manometers. It is simple to construct. It has greater accuracy, used to measure pressure, temperature and flow and other variables. It is used for measuring the difference of low pressures, right? The basic advantage of this inverted differential manometer is used to measure the difference in low pressures. Low pressure difference is measured by using the U-tube manometer. Already I have explained about this U-tube manometer. U-tube manometer is the simple manometer. In case of U-tube, it consists of a U-tube. One of its end is connected where the pressure is to be determined, and another end is open to the atmospheric. And in case of U-tube manometer, there is a heavy liquid filled in the U-tube manometer. The specific gravity of the manometer liquid, or generally we have used manometer liquid, is mercury. The density or specific gravity of the manometer liquid is more than the density of the liquid in the pipe, right? This is about U-tube manometer. Now we are going to determine the equation for the gauge pressure. One is determination of gauge pressure, another one is the determination of vacuum pressure. The case 1, determination of gauge pressure. Gauge pressure means is the pressure which is above the atmospheric pressure, right? The gauge pressure is used by using the U-tube manometer. Gauge pressure is basically defined as the pressure which will measure above the atmospheric pressure. Atmospheric pressure here will be taken as datum line. Gauge pressure will be measured with the help of pressure measuring instrument. Atmospheric pressure will be marked as a 0 as the scale of pressure measuring instrument. Right, now let us consider the following items for the above figure. P is equal to pressure at point B. P is equal to pressure at point B, and AA is the datum line. P is equal to pressure at point B, AA is the datum line, right? Now some notations here. So once the one of the end of the U-tube is connected to the pipe, because of the high pressure in the pipe, the mercury level moving like this towards right. This is the datum line AA. B is the point B. We are going to determine the pressure at point B, that is the pressure at point B. Now the liquid level in the left limb is H1. The liquid level, the mercury level, the manometer liquid level in the right limb is H2. Now we are going to write here H1 is the height of lower specific gravity liquid. H2 is the height of higher specific gravity liquid, this is the lower specific gravity liquid, this is the higher specific gravity liquid. Specific gravity of the light liquid, S1 is the specific gravity of the light liquid, S2 is the specific gravity of the heavy liquid. This is specific gravity S1, this is specific gravity S2. Density of the light liquid, density of the liquid rho is equal to S1 into 1000. Density of the heavy liquid, rho2 is equal to S2 into 1000. That means specific gravity of the mercury into 1000, right? Then rho2 is the density of the heavy liquid, right? Pressure in the left limb above the datum line, right? Now we are going to determine what are the pressures in the left limb, what are the pressures in the right limb, right? Here only one technique you are going to use here. The pressure in the left limb must be equal to pressure in the right limb, right? Based on this diagram, first we are going to determine what is the pressure at point B. Pressure at point B, PB, pressure at point B. Now pressure at point B, now we are going to take, this is datum line. Above the datum line, left side pressures must be equal to right side pressures, or left side pressure heads must be equal to right side pressure heads. What is the left side? This is left side limb, this is right side limb. What are the left side pressures? One is the PB, one is the PB, that is equal to pressure at point B plus pressure P is equal to, because of the H1, pressure at point B, that is equal to PB. Because of the H1 we have one pressure, because of the H2 we have another pressure. Therefore left side pressures, what are the left side pressures? PB plus WH1, this is equal to PB plus W is nothing but what? Rho G into H1. Rho is nothing but density of the flowing liquid. Okay, these are the left side pressures. These are the left side pressures. What are the right side pressures? We have only one column. Right side pressures is equal to, same formula, pressure is equal to WH. W is nothing but rho G into H is nothing but H2. Rho is nothing but density of rho 2. Right here this is equal to rho 1, density of the flowing liquid, density of the heavy liquid. Okay, clear? Now here the pressure in the left limb, the pressure in the left limb is equal to P, that is the pressure at point B, rho 1 G1 H1. Are you clear? And also pressure in the right limb is equal to rho 2 G2 H2. Right? Only one technique, pressure is equal to WH, where we are having H automatically having pressure. Right? Here we are having one H here, left limb, and another right side we are having one more H. Because of the H2 we are having one pressure, that density of one pressure. Because of the H1 we are having one more pressure, and that pressure of the fluid in the pipe is also another pressure. Right? Now equating the above the datum line, now we are going to equating the left side pressures must be equal to right side pressures. What are the left side pressures? What are the right side pressures? Right? What is left side pressure? Left side pressure is equal to, pressure at point P is denoted by P. Right? Left side pressures must be equal to right side pressures. What are the left side pressures? That is pressure P, that is because of pressure at point B, plus because of the height H1, because of the height H1 we are going to have one more pressure. Pressure is equal to, what is formula? WH1. Here this is nothing but H1, that is equal to right side pressures. What is that? Here also same formula, WH2. That means weight density of the liquid, weight density of the heavy liquid, weight density of the heavy liquid. Right? This is equal to P plus this is equal to rho density of the flowing liquid is rho 1, rho G into H1 is equal to rho 2 into G into H. Therefore pressure P is equal to pressure P is equal to rho 2 G H2 minus rho 1 G H1. This is the formula for the determination of the pressure at point B in case of YouTube manometer. Right? Are you clear? This is equal to pressure. These are the left side pressures. These are the right side pressures. Equating these two, finally we have the P is equal to, this is the formula. Right. So case 2, vacuum pressure. In case of vacuum pressure, here we have constructed, we are connecting the YouTube manometer at a pipe here. Because of the negative pressure here, the mercury level in the YouTube manometer is moving towards left side. Here also same technique. Here also same technique. We are going to determine the pressure at point B, that is denoted by P. Right? What are the pressures left side, the above the datum line? What are the pressures left side limb? What are the pressures right side limb? Pressures in the left side limb is equal to P plus rho 1 G into H1. Right? This is the H1. Here rho 1 is the density of the flowing liquid. S1 is the specific gravity of the flowing liquid. S2 is the specific gravity of the flowing liquid. Now, because of the vacuum pressure in the pipe, the mercury level move towards left side. The mercury level in the left limb is equal to H2. The liquid level in the left limb is equal to H1. Now, left side forces must be, left side pressures must be equal to right side pressures. What are the left side pressures? One is pressure, because pressure at point B, and because of the H1 one pressure, because of the H2 another pressure in the left side. Right side there is no water column above the datum line, therefore right side pressures is equal to 0. Right? What are the left side pressures? That is equal to P plus rho 1 G H1. Because of this H column, P is equal to, pressure is equal to WH, that is equal to rho G H. Here rho is nothing but rho 1, G H is nothing but H1. Therefore, because of this H1 liquid column, rho 1 G H1 is the pressure, plus because of the H2 heavy liquid column, pressure is equal to rho 2 G2 H2. Right? Rho 2 is the density of the heavy liquid. Density of the heavy liquid, rho 2 G2 H2. Therefore, pressure P is equal to, pressure at point B is equal to, this is equal to, what are the right side pressures? There is no right side pressures. Right? Therefore, P1 rho 1 G H1 plus rho 2 G H2 minus, this is the vacuum pressure in the pipe, that is equal to minus of rho 1 G H1 plus rho 2 G H2. This is the formula for the determination of vacuum pressure in the pipeline at a point B. Advantages of YouTube manometer. Technique of using YouTube manometer is very simple. Pressure measurement with YouTube manometer is quite economical. YouTube manometer will provide the accuracy pressure reading. YouTube manometer is quite simple in construction. Disadvantages: liquid will expose to atmospheric. This is only the disadvantage.